Hello everyone, January 30th. Alright, let's do this. Best team with no conflict. You are the manager of a basketball team. For the upcoming tournament, you want to choose the team with the highest overall score. The score of the team is the sum of scores of all the players in the team. However, the basketball team is not allowed to have conflicts. A conflict exists if a younger player has a strictly higher score than an older player. A conflict does not occur between players of the same age. Given two lists scores and ages, where each score I and ages I represent the score and age of the ith player, return the highest overall score of all possible basketball teams. So, okay, the score of the team is sum. So we want to choose a few of them. Okay, and the requirement of choosing a few of them is if we don't want to have conflict, so a younger player has a strictly higher score than an older player, that's not allowed. So in the first one, oh, there's no conflict. Nobody has, no, the younger players all have, wait, how many? How many are we choosing then? You can choose as many as you want. It doesn't really matter. It didn't say how many. Okay, so it's most like DP, right? We want to find, so we can say maybe the first one is choose everybody. The second one, we have age 2121. The best will be to choose the last three players. You are allowed to choose multiple people of the same age. The first three players. Because the last, example 3, the last player is, if you choose the last player, you cannot choose anybody else. Interesting. So maybe we need to sort by age. No, just a hunch, right? If we sort by age and then we choose the youngest, right? And that means any older has to have larger than the younger, right? Okay, let's sort by age. So see what happens. Sort by age, and if age is the same, we'll sort by their score. Okay, so in here we have 4, 5, 6, 5, and 2, 1, 2, 1. We'll sort by age. It'll be 1, 1, 2, 2. Wait, 5, 5, 4, 6. If that's the case, right? And then if we pick in age, right? So we say, now if we choose the high age, then everybody has to be smaller in the score sense. Or I can say, okay, if I choose, because eventually you will have to choose some players, right? Maybe we should sort by score. If I choose this player, okay, then, I mean, I always want to choose, it doesn't matter, like in the final result, somebody will be chosen, somebody will not be chosen, right? So basically, we should ask if a player is chosen, right? If a player is chosen, what is the maximum you can get, right? Let's say if this player is chosen, what is the maximum you can get? Or you can say this player is not chosen, what's the maximum you can get? So if this player is chosen, all right, that means we can only choose, when we can choose age is the same, so we can keep going down, right? And if age is the same, we can always choose it. If age, basically this one we set a limit, right? We set a limit saying because currently the smallest age is 1, right? And then the score associated with the smallest age. But then if you go, then the age need to be associated, so nah, doesn't feel right, right? Like if your age is smaller, if your age is bigger, then your score must be higher. Right? If younger player has strictly higher, which means if it's the same is also okay. So if I have, because I keep going, right? Okay, so okay, choose this. But then now I get a higher age and I cannot choose this, I cannot choose this. Okay, that's if I choose this. Then I say, okay, oh, if I want these 3, the maximum, I can choose 1 because I can, right? Yeah, we can actually keep the maximum, right? Keep the maximum because those people's age are all smaller than you, right? Just keep the maximum that we have, and then now when your age is gotta be bigger or equal to, right? So if your age is not bigger or equal to some of the previous, then you're doomed, right? So, okay, so we can say we'll pass in. We can say the maximum is 5, right? And now your age is 1. It doesn't really matter your age. It has to be bigger or equal to. Oh, unless you're no, because if we sort, when we go increase, so it's fine, right? So it has to be bigger or equal to, and then like this, right? And then in this one, we take this, so this will take 5. So we can say, okay, if I take this with age 5, then can I take it? Yes, I can take it. So I can take it. Okay, now we have 10, and age is 5, right? Still age is 5. And then next, this I cannot take it, all right? And then this I can take it. Then it's 16, right? This one we can get 16. And of course, right? Of course, an age, so it should be age and your index, right? Age and index. So it's O(n) squared. And then we start from each one, we decide what is the. Now I can also say, okay, I don't choose, right? I don't choose the first one. Then say, just give me the max of the remainder. So then, yep. I think this is a DP. We can actually have a little bit guess what should be the DP, what the DP state needs to be, because you see the length is 1000 and age is 1000, so these two can be your state. Okay, what do we have? So we need DP do you want to the maximum from this to the end, right? A maximum from this to the end. So what we given is maximum this to the end. But you go to either take this or not take this. Yeah, I think we can LRU cache this. Func tools import LRU cache. I mean, of course we can choose not to. So DP, we want to have index. I want to have pre-max, max age. Okay, and This one will return an integer. So we want to find, given the current max age, starting from an index, what is. But of course, first things first, we need to sort this thing. Okay, we need to sort this thing. So let's say, which is now age, and who should be the first? Age should be the first. So age score shall equal to sorted for AS in zip ages scores. All right, and now we have AS. Okay, so we sort. Now we call it AS. Oh, we cannot say. We cannot do AS. So age, okay, age score. How about this? Age score. We put them together, and then we sort. So it'll be age slow to big, and then if age is the same as score, will be slow to big, which is fine. So now we have this index, right? So index, we want the maximum. So if you are at the end, and then you will do the next one. So we say if index is equal to land age score, right? If this, then it should return 0 because you just go out, there will be no score. Okay, otherwise we'll take the current one or we don't take the current one. So whether we take the current one, we should do if, right, we can take the current one. So if age score index 1 is score is larger or equal to max age, then option 1 can be we take the current one, which is the max age. That's not max age, it's max score. Lord, the max score. All right, then we'll say age score index 1 plus dp index plus 1. Max score shall be age score index 1. All right, if the current is larger or equal to, then we'll do that. Otherwise, if it's smaller, then we cannot take it. Else, right? Which we can simplify. No. This is fine. Option 1. Option 2 is I don't take it. So option 2 is dp index plus 1. Max score. I don't take the current one. Okay. If I don't take the current one, then I don't have to include the current score. So yep. So these two, and then we shall return the maximum of option 1 and option 2. And then of course we're gonna ARU cache it. All right. Then we're gonna do is return dp. We're gonna start from 0, right? Max score initially is 0, and this should give us the result. .34 16 and 6. Scores, ages, best team score, scores, ages. Yep. Oh, we didn't check any edge cases. Shoot. Oh, this has happened quite a few times these days. Really? cannot do a million. That was surprising. I don't know. It's not fast enough. Now I am not sure. This is O(n) squared. I mean, it could be. I mean, I don't think area cache will be too bad. I mean, I'm surprised. Which means we need to be smarter. Smarter. How can we be smarter in this? Wait. Oh. Scores. It should be ages. So we have to... Oh, my bad. Yeah. I was talking about doing ages. That's why I was doing ages. But what we're doing is actually scores. Okay, so we change based on age, right? So we just sort it again, but we're based on age. No, we sort based on score. And then when the score is the same, we will do the age. And then as score goes up, we have the, because the score go up, all right? Your score, as you go, the score go up. So we need to find, so like whether we can take this, the score goes up. So the age has to be as the score goes up, right? Because every time you do, score goes up. So the previous, you have an age, right? And then the score goes up. The age has to go up, right? The age has to go. Wait, so hold on. Score goes up, right? So the age has to go up as well. So you have a minimum age, right? So the previous was a small score, so you have a minimum age. Because now you know your current score is definitely larger than the previous. So your age has to be larger than. So we basically, you need to swap these two. So it'll be S and A. So score age. That should be score age. That should be min age. Yeah, you're supposed to be min age. I don't even know what you're thinking. So basically, oh, it's 1, right? If it's larger equal to minimum age, right? So it has to be larger equal to minimum age. Well, hold on. It's not the minimum age, because as you go, right? As you go, we have the age. All we need to know, because your score is always going to be bigger, right? So as long as your age is larger than the minimum age previously, then it's fine. If your age is smaller and your score is bigger, then it's bad. So it should be larger or equal to minimum age. And then if you take this and your age is larger, so we just use the minimum age. Huh, isn't that the same? So under what condition you cannot take? Well, if you're smaller than the minimum age, right? If your age is smaller than the previous minimum age, then wait, hold. So your score is always going to be bigger, right? Your score is always going to be bigger. So which means your age shall be, so we need a maximum age. So your age need to be larger than the maximum age that's previously. That's going to be maximum age. It's maximum age. And we'll do this, right? Otherwise, we'll do the maximum age. Nope. Oh, because that should be 0. Score. Age. Right? Yep. Just swap the two. We'll see. Max age. Oh, how come the age still not right? That age is that I don't understand. Do at least do better. 138. I think this is 137. 132. Yeah, we did do better. We did slightly better. Slightly better. Interesting. We even do age is still not right. Yeah, we're not doing the score. We're doing the age, and it just. Yeah, 900 something. Yeah, 900 something. I don't know. What was the issue with this one? Maybe we don't have to sort? But if we don't sort, if we do not sort, what's going to happen? No, if we do not, I don't think that's the sort. I honestly do not think that's the sort. I don't know. You want to try? Yeah, for whatever reason, this one is timed out. I mean, we can write a bottom up. I mean, we know, right? We can say dp is equal to maximum age. And also say n equals. So dp will be index. So m shall equal to len score age, and n shall equal to maximum ages. Okay, so dp shall equal to 0 times n for this in range m age. I should probably do m plus 1. M is index, so this is fine. Okay, then, well, we shall do from the right to left, right? Like for the last one, we sort it for this one. So either take it or not take it. And then we do this for each. Oh my gosh, I need to analyze this. So what we say in this, these are ages. 0, 1, to the maximum. And these are the indices. Okay, these are index. The previous age, right? Okay, so we're talking about the previous age. We say if index is 0, we want to go from 0, right? We want to go from 0, and the age is 0. Now that's what we want. That's what we want to find. 0, 0. This is what we want to find. So we need to go ages. Maybe we need to go the last index. No, let's have to slightly different thinking. Which I think if we know the previous, okay, now we want to add one more. Okay, let's think this way. We know the maximum of the previous. Then we need to add one more. We want to see. So we can say we either add this or we don't add this, right? If we add this, then we need to know, right? If we add this, right, we know the score is getting bigger. So we have the age. So if we want to add this, we need to go find in the previous age is 2. Okay, so age is 2. What's the largest? Well, you have age is 2 or smaller. Right, and then we can do it. Otherwise, we just skip. Right, age is 2 or smaller. Age is 1. The maximum age is 1 or smaller. So what we're saying is add an index. Okay, add an index. What's the maximum is age is 0 or smaller. Well, that's definitely 0, right? Age is 1 or smaller. Okay, so we're talking age of 1 or smaller. That's 2. So these are all 0. So age is 2 or smaller. 2 or smaller is going to be 4. Right? 2. And everybody else is going to be 4. I mean, there's only age is only 2. Okay, next one. We're starting from 1. Right, which is like it's in here. So on here, age is 0 or smaller. The previous one, right? Age is 0 or smaller, that's a 0. So for you, now these should be all 4, because I have the maximum age. Wait, hold on. What do you want to do? What I want to do is when I consider the current one, right? I consider the current one, I have an age, right? I need to find the previous among all of them with the age at this, right? Age as the same age as mine, and with this or smaller. What is the? So what I want to find is at this index with this age or smaller, what's the maximum that you can get? So now we ask index is 0. All right, index is 0. I want to add mine, and my age is 2. So 1 or smaller, that's nothing, because my age, so the minimum is going to be age if I take myself, right? Yeah, so like in this, age is 0 or smaller, yeah, that should be 0. That should be 0. And this should be 4. Okay. Now we're at position 1. So from position 1, front to position 1, age is 0 to smaller. Well, I cannot, so I need to refer to the previous 0 or smaller than 0. Age is 1 or smaller, right? 1 or smaller, then we go the previous 1 or smaller 0, and for me it's 5, so I can take 5. 1 or smaller, right? 1 or smaller, either is previous 1 or smaller plus myself, right? Yeah, it's just previous plus myself. 2 or smaller is going to be 2 or smaller. I can't do 2 or smaller, because for me, because my age is 1, right? So the most I can do is 1 or smaller. That's it. I cannot go even higher. Age 3 or smaller, I cannot do, so that should be 0. 2 or smaller should be 0. Next one. But that is age 1 or smaller. 1 or smaller. So you need to find a maximum among them. So next one, index 2. My age is 1, so I can only go to 1. Everyone else will be 0. So for the 0 or smaller, we need to go for the previous one, 0 or smaller. It's 0, so that's will be 0. 1 or smaller from the previous 1 or smaller is 5, man, then it's 5, so it will be 10. 2 or smaller, that's nothing. Alright? So the last one previous, I should be 0, 1, 2. I can do all of them. So 0 will be 0. 1 or smaller, I can do. So 2, right? And 1 is small, so we can say previous 1 or smaller. I can do mine, so that would be 16. And this previous 2 or smaller. That's 0, so it will be 6. So the maximum is 16. Is that correct? I mean, maybe I only need to find the largest. I don't know. But in this case, I think we probably just need this. Okay. Then we can say for I in range. Now this is I in range M. Right? Then we say for J in range N, well, 1 to N plus 1. Say dp J shall equal to dp dpj plus this I age score. That's actually not right. We can go score I 1 plus 1. That's 0. That's score, right? So we can only go to that age. Beyond, we don't have to go. So we can say this can be plus equal to, and then we return maximum dp. Does this one work? Nope. Too much. Wait, I just want this. Zero, 4, 4. That's not right. Hold on, let me think. I think it's the first one is set it wrong. Okay, we can say dp first one. So score 0 age, right? This one shall equal to 0 1, and then 1 to the end. Okay, that's how I expect. Does everybody else agree? No. Yeah, I think I didn't quite figure it out. Let me think again. Yeah, because we sorted by score, right? We sorted by score. Okay, we sorted by score. So what we have is score age 1, 2, 3, 5, age 8, 9, 10, 1, right? Okay, so 0, 1, 2, 3. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Jesus. So the first one, we say score 1 or smaller. Now age. Okay, first one, age is 8. Right? The age is 8. Score is 1. And now we're asking if the age is 1 or smaller, what's the score? Should be 9 or smaller. Maybe this. Oh no. If I let's pose 1, everybody is 0. What's age 9 or smaller? Age 9 or smaller shall be 1 or 1, right? Let me just should be 2 or smaller. 2 or smaller. Or age 2. And we cannot take age 2 or smaller because if we take age 2 or smaller, the current age is 1, right? And my score is bigger than the previous score. So if I take age 2 or smaller, which means I need to go to the previous one to find 2 or smaller, and then that will include 2. And that's not allowed. So in this case, 9, oh, it just is 0. Okay, so I can go 1 or smaller, so 0 or smaller, that's always 0. The first one always 0. So age 1 or smaller, previous one, so I can just 2, 2, 2, 2, 2, 2, 2, 3, 2, 0, right? And that will be 5, 5, 5, 5, 5, 5, 5, 6. This will be 5, 0, 1, 1 or smaller. One or smaller. Previous 1 or smaller. I am 9. Right, I am 9. Which means I can only do 9 or smaller. the max is 3, and add my 3, it's be 6, which means for 10, previous 10 is going to be all the previous So you're telling me we have to do this. Okay, so these are all 0. Because now I'm going to do 9. So the first thing I can do is just 9 or smaller. So I look up, it'll be 3. And then these are all going to be 3. And now 10, when I look up, these will all be 0. So that will be 6. Okay? So next is 1. 1, I need to look previous 1, so it'll be 5. And then everything will be 5. And then we find the max of the last column. In that case, because everyone, all I want to know is previous. Yeah, so I get a new one, filter with 0, and then from this towards the end, we're just gonna fill a value. And then next one we're gonna do this, right? Which means if the new age, if the new one age is larger than the previous age, then we just do the previous plus the current one. Okay, so we have the age, and we have something small, then none of these can be used. We need to do the previous on this, then basically we will start. But what if we have a 10 again? If we have age 10 again, so in that we'll go back up to find the maximum. Yeah, what if we have a basically we're saying from this towards the front, what is the maximum age? No, what is the maximum score? 10 or younger. But in that case, we can choose to not include this. It shall be this. So you're going to 10 and find at the 10 position, which is the biggest one. Which means this should also be 6. And then when you find the maximum among these, right, so these will be all 5. No, this will be. Do we keep this one down? Yeah, we should keep this one down. This will be 1. This will be 1. This will be 3. But we current age is 1. That has nothing to do with the current age. What it is, and all of these shall be following the previous down. These shall just copy the previous down. That shall just be 1. That shall be 3. Which means from this, at this point, age is 8 or smaller is 1. Age is 9 or smaller is 3. Age is 10 or smaller, right, is going to be 6. Age is 1 or smaller is going to be 5. Age is going to be 2 or smaller shall be 5. Right? That shall be 5. 2 or smaller shall be 5. Age at 8 or smaller, so either 1 or 5. So it should be 5. That should also be 5, but this will be 6. 9 or smaller should also be 5, because otherwise it's going to be this. Which means every time you go out, the new one is going to be the previous one, right? And then we'll have to go one by one on the age. And for each one, if the age is larger than this, then I cannot, like the desired age is larger than this or smaller, right? This or smaller. We can take this and then we compare the previous, right? Yeah, just start from the one that we can, and then we'll take this and then we compare the previous, right? Compared to the previous. Now the previous means I don't take myself, I take this, or because the previous means is from age this or smaller. What's the previous max, right? And then, or it's choose me, but I cannot choose the previous to add to me. Why you cannot choose the previous to add to me? Because the previous can be because I'm 9 years old. So the previous 9 years old, so whatever this value is, I can add to me, right? And then 10 years old, I can also add to me, right? I still don't feel right. list up until this point, I want to know the maximum score with different age, right? With 0 age, well, nobody's 0, so it's 0. With 1 age, which means, and its score is sorted, right? Score goes up. Score goes up. Right? Score goes up. Which means, because at this, does it even really matter? Okay. Hold on. Let me think again. I come in with my score and my age. Okay? That's the current index. I have my score and my age. And then I want to find out with my current one if I want to, I can contribute. Oh, I don't need to contribute. Then I want to find at my level what is the maximum score with age this or smaller. So if my age is too big, then I cannot contribute, right? So I have to start contributing at my age. Okay, then I want to see how much I can contribute from this age, right? And then we look up, right? That's the previous, this age or smaller. So they are all smaller. The score is smaller, so that's fine, right? It's fine. So I have my age. Okay, I have my age, and then I look up. The previous one at this age or smaller will have a score, and now I can definitely add to it. I can definitely add to it, and then that will be the new maximum for this position, this age or smaller. Okay. Now, if I need to go even higher, like age is higher than me, okay? So I say at this age, like age is 10, like I'm at 9. I say, okay, at my current, I want to find 10 years or younger. Then it shall just copy me over, right? It shall just copy me over because it's the maximum. It should be my age or younger. So if it's gonna be even older than me, right? If it's older than me, so from my perspective, this is the most I can do. And then I should compare to the previous, which means we start from this. We're gonna add to the previous. Right, and then for the next one, it'll just be this and a compare. For this, compare. For this will be this. Everything will be the same. Right, so this, which is this, and then this, compare. This and this, compare. So, which means if we do 1, okay, then we have this from this towards the end. Okay, we are gonna just make this all that, and then okay, let's do the other example. Let's do this. Okay, we have will 1, 2, 3. Okay. So we have 0, 1, 2, 3. No, 0, 1, 2, that's it. So again, so first one, age is 2, score is 4, so we go to this one and then fill up, and that's all we have. Next one, age is 1, so we start from 1, so it will be 5, and then this will be 5. Next one, age is 5, so we go 5, so we add, it will be 10, and this just compare, so that will be 10. Next one is 6, so it will be 16. So what I'm saying is, so the first row shall be, so first row shall be for j in range from age, right? So from this towards n plus 1, dpj shall equal to this. Okay. And then for I in 1 to m, right, 1 to the end, we're gonna start from this as the age, from this age, right? Well, I mean, we should be dp, this is the age, shall plus equal to dp this. No, plus equal to this. Okay, then we say for this, equal from this plus 1 to m plus 1, right? Every single one. dpj shall equal to the maximum of, because I cannot use myself, but I can do dp j original and dp score age I 1, right? That's the age. Yeah, this is the score. Score age, so we sort by score and then by age, right? The age to the end. This is the same, so we get the age plus the score, and then for every single one should be this, all right? And then at the end, maximum this, and then we'll return. Okay, this one pass. Okay, this one pass. They all pass. Okay, so that I translated. Let's see how long does it take to run this. It looks to be a lot faster. We can try this. January badge. See you next month. I mean, should I put it? The runtime is the same. Oh, it took so long to translate. I mean, the runtime of this is I mean, it's the same, right, as solution 1. Both OMN, where M is the max age and no, M is not. M is length of scores and N is the max age. but I guess a bottom-up solution is faster, is easier, has lower overhead. I don't know. It took a long time to translate. I don't know. I mean, my ability to DP just dropped significantly. Right? It's not that hard. It just took me a long time to figure out. I mean, top down I tried, but top down just didn't work. Bottom up. Ooh. BIT. Damn. Segment tree. I don't know. I just got timed out in the top down. Unless our just understanding of the top down is wrong. Probably the understanding of the top down is wrong. Alright, I don't want to read today. It's already late. Alright, I think I have to learn this tomorrow. Hopefully tomorrow's not too hard, so I don't get longest increasing subsequence. Oof, longest increasing subsequence. I guess that's very different. Yeah, I'll figure this out tomorrow. I mean, we did it, but it took so long to understand this. Alright, I'll see you guys tomorrow. Adios.